Okay. So in this session, we are going to get into the another topic, that is extension of the Hazy diagram. That topic is called lattices. Okay, topic name is called lattices. So in your previous class, you are dealt with the topic is called construction of the Hazy diagram for the given poset with respect to the relation. Okay, there which you are applied the relation between all the pairs of the elements, this not all the pairs, you will be applied simultaneously. If it is related means you can upgrade the level. If it is not related means you can retain with the same level. Also, we are with the basis of the Hazy diagram, you are obtain the GLB and then LUB concepts. Okay, already I've told you that can be combinedly, they can ask as a single 10 mark. Sometimes they will be provided the set poset. Okay, they just simply ask you to check whether it is a lattice or not. That can be also asked as a single 10 mark as a combined question. So you have to be ready in both the cases. So here lattices topic is completely related with the topic GLB and then LUB. I'll say why it is I have mentioned like that. Okay. So here before that, in your previous session, you are discussed on graph like you will be attained GLB and then LUB. At some cases, you will be getting the answer as the empty set. Hope you can remember that. You will be attained that empty set. Why that empty set was attained? Because of the reason you could not predict which one can be the greatest, which one can be the least. So instead of that, there might be two elements or three elements are at same stage. Okay, same level means that time you should mention empty set or 5. So that will be the answer. So from which what I need to conclude, between two elements or in the three set element, there might be the chance to get empty set in your either GLB or LUB. Now I come back to the definition of lattices. What lattice definition says. See here, lattice definition says like lattice is a poset. Okay, it is a poset which has, it's a very important line, every two elements has GLB and then LUB. GLB and then LUB. So here, if suppose if one pair does not have the GLB or LUB, means that time if it has empty as the answer in GLB or at LUB, means you should not say that poset as the lattice. Okay, lattice is a poset. It has to satisfy extra one condition. If you take all the pairs of the set, it should attain GLB and then LUB exist. Okay, if it does not exist means then we should not call that given poset as the lattice. Have you understood that this definition, lattice definition?
Sir, can you repeat once?
Yes. Actually, it's a poset. You will be provided one set. You will be provided one set with respect to relation. Okay, in which you are going to draw the Hazy diagram first. That is your first task. You will be constructed the Hazy diagram. For which Hazy diagram, you need to check between every pair of the nodes, every pair of the vertices of the set, whether it has the GLB and then LUB. If suppose for one pair, if it is not having the GLB and then LUB, mean simply you can just close the problem like it is not a lattice because of this pair or that pair will not have GLB and then LUB. That's it. Okay. In this case, if it not satisfying any one of this, like if it is not having GLB for one pair or if it is not having GLB for, sorry, LUB for one certain pair, means you can simply close the concept like it is not a lattice. That's it. Have you understood now?
Yes, sir. Thank you, sir.
Okay, thank you. So now we can, before entering into the illustration of the lattice, quickly we can just see the denotion of it. Usually, 1 minute. Okay, yes, I can write here. See here, usually GLB will be denoted like star. Okay, in your general GLB and then LUB, you are applied for the set, that set may have like 3 elements or 4 elements or 5 elements or sometimes 2 elements also. For those elements appeared in the set, you are determining the GLB and then LUB. But in your lattice case, you are supposed to investigate only between two elements, okay, not more than 2 elements, okay. So here, there you are going to apply GLB and then LUB between 2 elements of the set. At the same time, its denotion sometimes instead of GLB or what is the another name of GLB? Already I have told you in your previous session. What is the alternate name of GLB?
Infimum.
Very good. No. Supremum. Sorry. Yeah, you're right. Actually, upper, super. So I used to follow the way like, okay, supremum, and then this is infimum. Sorry. Okay. So infimum and then supremum. So I always used to follow the shortcut like upper, super. So supremum, upper bound. So infimum, lower bound. So here another notation. So GLB between two elements means that they will be applied star between them. Okay, star, A star B. Okay. So LUB means A encircled plus A plus B. Okay. In another words, they can call it like A meets B or A product B. Okay, this is also called like a GLB between A and B. So A meets B or A product B. Okay, next A join B or A sum B. So these are the other terms you should know instead of GLB and then LUB. You should not forget this. So in another notations like A star B, that is also called like a meets B, right? So that can be denoted like A and B, A and B. So this is A and B, or they can easily denote like A dot B or simply the AB, or most of the times they will be used A star B only. Sometimes they will be used A dot B. So likewise, A plus B also to be called like a join B, that is called ARB. That is nothing but A plus. When you keep in your mind, this is plus, right? This is sum. So whenever sum comes, disjunction symbol should come, right? Whenever the product symbol comes, that time and symbol you will be used. So for the sake of confusion, sometimes they will be given determine A and B and ARB. They will be asked the question like that. So you need to be aware about the notation, what it tries to explain, so that you can easily apply the concept in your Hazy diagram to determine GLB and then LUB for the same. Have you understood up to this? Is this clear? The notations also? Can we step into the examples? Have you understood up to this?
Yes, sir.
Yes,
Okay, fine. Thank you. Thank you for your response. Okay, now we can enter into the example of that. So here I can take two examples. So in which our task is assigned to check whether A is lattice or not, same B is lattice or not. Okay. So there already I've told you the process is nothing but you need to apply the checking process between every pair of the vertices which appeared in the Hazy diagram or which appeared in the set. Okay. Sometimes they will be given the set. Your duty is to draw the Hazy diagram first and then you need to check. Okay. So even though they will be provided the set alone, your ultimate task is you need to first construct the Hazy diagram properly. Then only it will be easier process to determine the GLB and then LUB exist or not. You can easily check that. So now, so I should check between every pair of vertices. Like better I can just choose like x star a and then x plus a. That means GLB of x and a, LUB of x and a. So to determine GLB of x and a, first I need to know LB. Once if you get proper practice on it, you can skip writing the LB and then UB values. That is not a required one. Okay. Usually they will be considered the marks only on this step, whether you have written correctly GLB or LUB. That's it. Okay, so until you get a strong that means good enough to write the direct way to write the GLB and then LUB, you can just simply follow the proper way. Otherwise, once if you get proper practice on it, you can just skip those steps. Okay, first, what is the LB of X and A?
X.
Very good, X, only X. Okay, what is the UB of X and A?
Y.
What is the upper bound? I'm just asking upper bound.
CDYE.
CD. Why not? It can be A.
Yes, sir. A and
Oh.
B.
So except X, all other elements will come. Right? Am I right?
Yes.
No.
So how
There I
B
have
won't
done a
come,
mistake.
so B and E
Very good.
won't
The B and E won't
B,
come.
B and B
E
and
won't come. E, sir.
E. Okay. Very good. So E C D. E C D. Okay. So after
So
this, now you can write down the X star A.
sir,
That means greatest.
sir,
Yes, please.
how
Sir,
E
in
won't
upper bound, why should be there? Na?
Sorry.
So Y is also there.
Yes, Y should come. Sorry. Y should come. Yeah, I have missed. Sorry.
excuse me, sir.
Yes, please.
So why E won't come?
Yes. See here, in this case, for your X and A, if you consider E means, see here, E is the upper bound of X because it is in the upward directional. But when you take with respect to A means, it will go in this path like ACYE, otherwise ACBE. So it will get down and then it will start rising the directional path. So see, because of that reason, E should not be included in this set. Is it clear?
So it shouldn't, like, if we are going in one direction, so it shouldn't even go down.
Yeah, exactly. Always you should go in a upward direction, not in a parallelly upward and then downward. You should not take the elements like when you get into the lower bound, it should be in a exact downward directional path. Okay. So that's what we have discussed in the previous section. Okay.
Okay.
Is it clear?
Yes, sir.
Okay, now you can just straight away you can say the GLB of X and A. That means X star A. What is the answer?
X, sir.
There is only one element X alone. Okay, so X will be the answer. Next, X plus A.
A, sir.
A. Okay, that's it. So likewise, you need to check for every pair of the vertices. For example, next XA is over. Next XB. Next XC, XD, XY, XE. Likewise, you need to check AC, AB, AD, AY, AE. Next CB, CD, CY, CE. Next BD, BY, BE. Next DY, DE. Last one YE. So likewise, you are supposed to check between every pair of vertices. You can just check whether it exists GLB and then LUB. For this pair, it is exist because it is having. Okay. So likewise, you are supposed to check between every pair of the vertices of the Hasse diagram. Then only you can confirm whether it is a lattice or not. Okay. For that example, just I can write another two sets. With that I'll close. Okay. Randomly I can choose, not in order. So I can just, for the practice, I am just choosing another A star D, A plus D. Okay, that first you need to determine LB and then UB. Okay, so what is the LB of A and D?
A and X, sir.
Very good. A and X. Superb. Very good. Okay, likewise UB.
D and Y.
Y and
Very good. Super. D and Y. Now can you directly, very good. Now you yourself can realize you are just practiced better in a better way, so that you are saying the answer in a quick way. Okay. So likewise, you should get a proper practice by solving more number of problems. Then only you will get strong idea to easily predict the answer, which will be the exact one. Okay. So now, what is the GLB of A and D?
A.
So
A, very good. Next, what is the LUB of D? Sorry,
D.
A.
D.
That's it. So for this set also, for this pair also, it is exists. So likewise, your duty you need to check for the remaining pairs. You already have verified. So it is lattice because it satisfies the GLB and then LUB exist for every pair of the vertices. Okay. So now we can
so won't it
say.
take a very long time to write all the pairs in the exam?
Yes, actually in your exam, it is enough to show 4 pass at least, 4 pass. Okay.
Okay, so
So once you get the practice to skip the LB and then UB, that time not a problem. You can easily predict the way. Okay, you itself can realize after practicing 3 or 4 pass, you itself will be skip the step to write LB and then UB. It is not required. The marks will not be considered for that. But in your exam point of view, you should draw the Hazy diagram properly. If it is a lattice means you need to show, you need to present at least 4 pass of the vertices. Then you can confirm it is a lattice. Okay. Hope you have cleared the
okay,
question.
so
Sir,
Yes.
one thing, like if
Yes.
we get a pair which for which it doesn't have, so can we like close it that since it does not have this one, so it's not a lattice.
Yes. If suppose directly, if you are able to pick because of this pair, it does not exist GLB and then LUB means that pair alone is required. That pair alone is more than enough. It is not required to show other pairs. Okay, with that you can close the problem. Because of this pair, it is not behaving the property of lattice. That's it. Clear?
So, sir, like if we show some other four, but there is a pair for which it does not exist, then what should we do?
Sorry. What is your question? Last point.
Like we can show like four such pairs for which it does exist, all the GLB and LUV.
Okay.
But there is such a pair for which it does not exist. So what should we do in that case?
There is such pair. What does not exist mean? Sorry.
For which GLB and LUB does not exist.
In which pair, if suppose if one pair is not exist GLB and then LUB, right? That's what you're
Yes,
asking.
yes.
Then
But
you can
there are
close the
four
problem.
pairs for which we had shown that like it
No,
is
actually,
exist.
at least roughly you need to check when you present in the exam, the even if it is a lattice means you need to show like by showing 4 pairs showing the GLB and then LUB properly for 4 pairs at least, so that the marks will be considered. Simply you should not write the answer like by drawing the Hazy diagram and then it is a lattice. You should not close the answer like that. After before that you need to present example like by showing 4 pairs at least. That's what I'm saying, in which in between itself you are getting one pair is not getting GLB and then LUB, not a problem, you can close the answer. Okay, straight away if you are able to predict if it is not a lattice means not at all problem, you can simply mention, you can code that pair. Because of that reason I am not getting GLB and then LUB, so it is not a lattice. You can close the answer like that. But if it is a lattice means there at least you need to present 4 pairs at least. That's what.
Okay, sir.
Okay, fine. Now you will get idea on this second problem. See here, I can say the answer directly. It is not a lattice. Can you just point out for which pair it does not exist
Sir, D
GLP and
and Y.
very good, superb. Straight away he has picked very easy example at the quick answer. Superb, very good. So here D star Y, D plus Y. Okay, so in which D star Y, that means DLB of GLB of D and Y. So first if I determine LB for that, so I can able to determine LB. What about the LB for that? Can you just try to say first LB of
A and X.
A and X? Very good. A and X. Next, what is the upper bound for that?
A.
Sorry.
Empty set. So
Very good. Empty set. Okay. So here you will be getting in your GLB as A as the answer, right? Sorry. Yeah.
Yes.
A as the answer. In your D plus Y, even in your UB itself, you are getting empty. Certainly, it will be repeated. So because of that reason, I can close the answer. Any other guys? Anyway. Sorry.
So GLB of D and Y, like D and Y do not have an element in common. So like, how can we write X there? Like, X is the GLB for. Okay, sorry, sir. Never mind.
No problem. No problem. No need to ask sorry for this. No problem. Okay. Anyway, it's a good thing to explore your views at the same time, to explore your doubts, so that others also can get a clear idea on this. So okay. So likewise, okay. So here, if it's not a lattice, straight away the person has predicted the answer, right? So simply you can mention here it is not a lattice. Okay, that's it. For that thing itself, it will be given full marks for that, 5 marks for this. Okay. To write the whether it is a lattice or not, that time usually it will be granted 5 marks for that. Okay. So by keeping the same diagram, just ignore this pair. Okay, I'm just asking extra additionally, I'm just asking any other pairs which does not exist, GLB and then LUB. Any other pairs? I can ensure that there will be the other set of pairs will be there.
D and E.
Sorry, very good, super. D and
D and
E. 2 persons have said, okay, D plus E and then D star E. You will check. In one case, you will be attained empty. Any other?
CD.
CD. Yes, good. CD. Okay. So likewise, you can say, I think another pair also, AB also will be there. I think my guess, AB also will be there, not to show the GLB and then LUB exist. Okay, that's it. Very simple concept to check whether it is a lattice or not, by checking out for every pass whether it is having the GLB and then LUB, both the things. Okay, not only one. Okay, it
So
should have both.
for
Yes,
AB, wouldn't Y be LUB?
For what pair you are asking me to check?
AB.
AB. Okay, let us pick A star B and then A plus B. Okay, in which what is LB of that? AB.
X.
X.
X. Very good. Next, what is the UB for that?
C
Y.
comma Y.
C comma Y.
Yeah, C comma Y. Okay, in which, yes, I think it is exist, right?
Yes, sir.
Yes, sir.
Yes. Okay, it is exist. So not for A and B. So what is the lattice definition says? If it vanish for, if it not satisfying for only one pair, then simply you can close like it is not a lattice. Okay. So that's it. So just roughly I have said like B maybe. I'm not confirmed about it. So likewise you can predict D, E. So other pairs also. That's it. Have you understood on this example? Is it clear?
Yes.
Yes, sir.
Okay, fine.
So one thing, so
Yes.
in this case it's easy, like there is no connection, so we can
Yeah,
predict.
yeah.
But there
Good
are some
question. Good
cases
question.
like where
Good question.
upper bound is like means two elements exist, so we are not able to determine the greatest lower bound or upper bound.
Good question. Good question. So that time there is no other way. You are supposed to check whether it is a lattice or not by involving all the pairs of vertices. Okay, I have just taken very simple example, silly example to show that. But it's your duty. You are supposed to check between all the pairs. Anyway, it's a good approach. Good question. Super. So sometimes, see here, you will get another shape. What we have solved already one problem in the last session. You also can pick that example itself. You can just try to check whether it follows the lattices property or not, so that you will get some idea. Okay, these and all will come only when you have proper practice on it. How you have predicted, like you can just simply explore your practices on by picking out examples of pairs. So automatically you will guess. Sometimes I always used to check first between opposite sides like A, B, something like. Then I'll get some clear idea. So if it satisfies means surely you will get some GLB and then LUB exist between every pass of vertices. See, because most of the times if it is connected means here always will be exist. This sides will be exist. So there is no rule to not to exist for these sides. Okay. So always it is enough to check between opposite sides. Okay, so that will be on shortcut. I'm not saying this will be the exact method you should follow. So likewise, how I have predicted this shortcut means because I have slightly practiced on this problem, so I have just got this idea. So likewise, you will predict some another techniques to solve the problem in easier way. So that can be derived only when you do your hard work to get into some proper practice on it. Clear?
Yes, sir.
Sir,
Okay.
can you check for D and B?
D and B. Okay. D star. Okay. So first let me write UB and then LB for that. What is the UB for that? D and B?
Null.
Empty set.
Yes, yes, very good. So here empty. So no need to proceed for the next one, LUB. So you can close it. Okay, because you are getting empty, you can. Very good, good example. So likewise, you can predict the other pairs also. Okay, so that's it. Have you understood
So,
on this example? Can we
so,
get into the another one? Yes, please.
so
Is there any
one
doubt?
pair is enough, no, sir.
Yes,
Like
yes, one
to.
pair is enough. That's what I have already told you.
Okay.
It is
Okay.
not required to pick all the pairs which are not satisfying the lattice's property. If it is not a lattice means it is enough to show only one pair not satisfying the GLB and then LUB exist on that. Okay, it is not
Okay.
forcefully to try with the other examples also, other pairs also. That's what I have already
Okay.
told. You can
If
simply
it's
use that.
lattice, then 4 is enough.
Yes,
Like if
yes,
it is okay.
yes. Okay,
Got it.
good.
Thank you.
So before entering into the next one, you can just fill the attendance form. 1 minute. Yes, I have shared the attendance form in your meeting chat. You can just fill the attendance form. Very good, quick response. Thank you. Okay. Next, let us enter into the next problem. Quickly, I can complete the session soon. Okay. So just maximum 5 minutes. Okay. So here, next problem. So here, next problem is D that 30 and then divisibility symbol is given. Is this lattice or not? That's a question. Okay. Here, D30 means divisors of 30. Everyone can able to see the screen?
Yes, sir.
Yes.
Okay, fine.
Yes.
Thank you. Okay. So here, D30. So with respect to the relation divisibility. So first let us write what are all the divisors of 30. Quickly you can list out the values. 1,
2, 2,
2, Very good.
Three.
3,
3,
5.
5,
6.
6, 10, 15, 30.
Thank you. Okay, good. Okay, after this, they ask you to check whether it is a lattice or not. So that for this thing, it is very important to know the Hazy diagram further. Then only it will be easy to predict whether it has GLB and then LUB for every pass. So first, let us enter into the construct the Hazy diagram for this D30 with respect to the relation divisibility. So here, so I can just start with the graph like 1. Next, 1 is divisible by 2. Yes, okay. So I can upgrade the level. So I can have the connection between them. Next, 2 is divisible by 3.
No, sir.
No. So same level. But 1 is divisible by 3. So I should have the connection between them. Next, 3 is divisible by 5. Can I upgrade the level?
No, sir.
No. Next, after this, 6.
2 and
Next
3.
level.
2 and
Ah,
3.
Next level,
very
so.
next
2 and
level. Very good. So 6. So 2 and 3. After this, 10. Same level or next level?
5
Same
and
level, so.
5
Same
into
level.
6.
Very good. 5 and 2. Okay, very good. 15. 10 is divisible by 15.
Same level, 3 and
it's the
5.
same level.
Uh,
3 and 5.
Last one. 30. Same level.
6, 10, 15.
Next level.
Above level. Next level.
Very good. That's it. So here 6, 10. Last one. And then
15.
15. Now I hope you can able to see this structure in the form of cuboid, right?
Yes, sir.
Yes, sir.
Okay, in your note you can draw perfectly, but in this the digital pad I could not draw more perfectly. Okay, anyway you can adjust with the diagram. Okay, so here after this to check whether it has the GLB and then LUB between every pair of vertices. Likewise, you can just check properly between the vertices, like 1 star 2, 1 plus 2. Likewise, so 1 star 5, 1 plus 5. So 1 star. So likewise, you need to check between every pair of verses. So I'll say the answer for that. It is a lattice. It is a lattice. Okay, it's your duty. You can just check properly.
For showing that it is a lattice, will we have to write out every possible connection, or
No.
we can?
You can just pick at least just 4 pass. That's enough. Because
Okay.
if you would see in a like a overlook, you will say whether it has GLB and then LEB or not. Okay, once you get proper practice. So in the exam presentation, you are supposed to show 4 possibilities. 4 pass you should be shown. Okay. Okay, next. So there are some properties if one set is lattice means. So what are all the properties that here in your lattices? Actually, these 3 properties will be there. So before that, there is one more additional properties there that is not comes under lattice. But anyway, you should know that. See here, idempotent means in your group itself, we have discussed about this topic. That is idempotent is nothing but in your group you are discussed like a square equal to a. Okay, so likewise here there in your group G comma star was used. There star defines any binary operation. Here instead of the star you may have 2 cases, that is GLB and then LUB. Okay, so both the symbols should be involved in this lattice properties. So here idempotent between the same elements, if you apply the operation between them, you will get the same answer. Commutative, same, a star b equal to b star a. Here a plus b equal to b plus a. Associative, same, even if you change the positions of the brackets, you should get the same answer in both the sides. Absorption law, here you should use both the notations LUB and then GLB. If one element is dominating in the left hand side, that dominating element will be the answer. See here in this case A is dominating, so A will be the answer. So likewise, if B is dominating means B will be the answer. So likewise, in your absorption law, even if you change the positions of the denotions, notations, you will get the same answer. Whatever the domination element will be there, that element will be the final answer. Have you understood on this the properties?
Yes.
Okay, last
Yes, sir.
with the del close. Okay, see here. If you could see with respect to the algebraic system means that thing, these two symbols will come. It has to satisfy the conditions are already I've told you commutative, associative, and then absorption. That's it. If one a lattice of an algebraic system will be there means it has to satisfy three conditions. One is commutative, associative, absorption. That's it. Okay, in the next session, we can enter into discuss the classification of the lattices. So like what are all the divisions will be there, like a sublattice will be the definition, and then complementary lattices, complete lattices, distributive lattices. There are other classifications. There we are not going to enter into another new topic, just we can see the definition with respect to the examples. That's it. Okay, with that we can complete this model. Is there any doubt up to this? Is it clear? Yes, please.